will explain more about question 1 and explain the meaning of differentiation and techniques of differentiation. What is differentiation? Differentiation is the process of finding the derivative of a function which represents the instantaneous rate of change of that function. It's a fundamental concept in calculus used to determine how a function changes with respect to its input variables. This is the example of differentiation that can be found in real life, which is speed of a moving car. If a car is moving and its position at time t is given by a function st, where s is displacement, then the derivative ds divided by dt gives the instantaneous speed of the car at any moment t. This tells you how fast the car is going at the exact point in time, not just over time interval. Definition of derivative. The geometrical meaning of the derivative of y equals to fx is the slope of the tangent to the curve y equals to fx at the x fx. The first principle of differentiation is to compute the derivative of the function using the limits. This is the example of geometrical representation, where we let the function of the curve dy equals to fx let us take a point p with coordinates x fx on the curve. Take another point q with coordinate x plus h, fx plus h on the curve. Next, I will explain all the key points on this slide that has been stated on the graph. Where curve y equals to fx is original function, point p and q, p is located at x so coordinates are x fx, q located at x plus h so coordinates are x plus h, and fx plus h. The blue line represents the second line, which connects two points p and q and represents the average rate of change of function between two points, and its slope is fx plus h minus fx over h. The second one is the tangent line in the red color. As h approaching 0, point q move closer to p. The second line becomes the tangent line at point p. The slope of the tangent line is the derivative, where f prime x equals to h approaching 0, fx plus h minus fx over h. And last but not least, this graph shows geometric meaning of derivative. The derivative at point x is the slope of the red tangent line. The change in y equals to fx plus h minus fx, and the change in x equals to h. So the slope of the second transition into the slope of the tangent sq approaches p.
Today I'm going to explain about how to find dy dx for this following function. So firstly, we need to write this function this way. And by looking to this function, we know that we need to use product rule, which is then we need to let u, then find the u prime. Firstly, to find the u prime, we need to bring the power to the front, and the power is minus with 1. So after bring the power to the front, we need to multiply it with 4. So the u prime will be fx because the power has been minus with 1. Then we need to find the v. The v is cos 5x minus 2. So the v prime is the derivative of cos is negative sign. So after find the derivative of cos 5x minus 2, we need to find the derivative of 5x minus 2, which is 5x minus 2, the derivative is 5, so we need to multiply with 5, and then the 5 multiply with negative sign, and this is the v. After we find the u prime, v and v prime, we need to substitute in this formula, which is u is 4x squared, v prime negative 5 sine 5x minus 2, v is cos 5x minus 2, and u prime is fx. Then we need to multiply negative 5 with 4, so it will be negative 20x squared sine 5x minus 2. Then bring the x to the front, so it will become x cos 5x minus 2. And then we rearrange it, bring this one to the front, and this is the final answer. Next, I'm going to explain on how to find dy dx for this function. Firstly, we need to write this function in this way. And by looking to this function, we know that we need to use quotient rule, which is that we need to let u. Yes, this is u, this is the u prime is 3. Then we need to find the v, which is sine 2x. Find the v prime. The derivative of sine is cos, so it will be cos 2x. Then find the derivative of 2x, which is equal to 2. So we need to multiply it with 2, then bring the 2 to the front. After we find u prime, v, u, and v prime, then we need to substitute it into the quotient rule formula, which is u prime is 3, v is sine 2x, u is 3x plus 1, and v prime is 2 cos 2x. Then v squared is sine 2x. Then after we substitute into the formula, we need to bring this power inside, then it will become like this, sine 2x, sine power 2x. Lastly, we need to bring the 2 to the front of 3x plus 1. And this is the final answer.
So as you can see that this question, we need to put the over the rest for every term in front of the solution. But before we need to put the terms, we need to put in the square bracket, which is this. After that, as you can see, we need to differentiate for every term. in these terms, we need to use the product rule, which is log dy ln to x. First, we need to let u equal to y and then v equal to ln to x. After that, we will differentiate y, which is dy over dx, because y is not a constant. And then here for v prime, we will differentiate outer and inside, which is 2x. And then as for this, after we differentiate out to x, it will become 1 over 2x. And then we differentiate inside, which is 2x, it will become 2. After that, we will expand multiple, okay, it will become 2 over 2x. And then we will cancel 2 over 2, which is 1 over x. And then we will substitute in this formula, which is u v prime plus v prime. This formula is from product rule, so we get this. And then we will bring this answer in here, which is y ln 2x. So we will copy back this, and then we will differentiate with the power of 5x plus 3. We need to solve it outside and then inside. The outside, which is 5 d5x plus 3. It doesn't change because it stays the same. And then we differentiate 5x plus 3, we get 5. So to 10, 6, 5, we will differentiate with that. Sec 2x. For this, we differentiate outside and inside too, which is sec 2 6y or 10 6y. We will differentiate and get this. As for 6y, we differentiate and get 6 dy over dx, because y is not constant. After that, we will multiply for every that has the bracket, which is y over x plus ln to x dy dx minus this will split here x plus 3 equal to, for this one we will multiply in, we will get 6 sec 2 6y dy over dx. Then after that, dy over dx we put in the left hand side, which is that dy over dx we will put in the right hand side. So then we factorize dy over dx. On the right hand side, we just copy back. Then as you can see, dy over dx, and here is this. This is multiplied. The multiply we bring back to the side because it is contained denominator.
So for this question, we need to find the value of this function to treat decimal places using the linear approximation. Okay, so for the first step, we need to let x equals to 63.98. So the first step, x equals to cube root of x minus over square root of x, where x is equals to 63.98. So after we find x, we need to find x0. So how do we find x0? x0 must be a perfect square or whole number, and it is very close to the value of x is now. So x0 can be 64. For the second step, we need to find the change in x value. So change in x value is equal to x minus x0. So as we know, x is equal to 63.98, and then x0 is equal to 64, so it will become negative 0.02. And then for your information, the value here must be a very small value, or 0 point something, because the change in x value must be in the range from negative 1 and 1. So for this step, we need to differentiate the x function to the power 4. So this will become x to the power of 1 over 3 minus 2x to the power of negative 1 over 2. Then we need to differentiate the f prime x. So the function here, the power, we need to bring to the front, so it will become 1 over 3x. And then the power here, we need to minus with 1, so it will become 1 over 3 minus 1. Then minus the power here, bring to the front, so it will become negative 1 over 2x. And then the power here, we need to minus with 1. So the answer will be 1 over 3x to the power of negative 2 over 3 plus 6. It is negative 80. And then x the power of negative 3 over 2. The first step, we need to find the f(x0). So f(x0) is equal to f64. So we need to substitute the 64 into the f function here just now. And then we need to do the same thing with f prime x0, which is f prime 64. And then we need to substitute the 64 into the f prime x function just now. So the f(x0) function will become like this. We need to substitute the x64 into this, and it will become 15 over 4. For the f prime x also, we need to substitute 64 into the f prime x function just now. So it will become like this, and then we will get the answer, which is 35 over 1536. So for the last step, we need to use the linear approximation formula, which is fx is approximately to f(x0) plus f prime x0 multiplied by change in x value. So the fx value will become f 63.98 approximately to f which is x0, which is 64, and then f prime x0, which is f prime 64 multiplied by the change in x value just now, which is negative 0.02. So the answer for f(x0) is 15 over 4, which you can get it from here. And then for the f prime x0 is 35 over 126, which you can get from the step 4 just now. And the change in x value is negative 0.02. So the final answer will be 3.750, and it must be in 3 decimal places.
In conclusion, the techniques of differentiation such as the power rule, product rule, quotient rule, and chain rule are the essential tools to find the derivative of various functions. By mastering these methods, we can analyze rates of change, solve the real-world problems, and gain our understanding of calculus and its application in science, engineering, and economics.